Okay, this is number 35, which is one I think it's very possible it'll show up on the test because it's actually on a quiz, so it's also one of your homework problems. We wanted to make sure we did. So it says find the exact value of the trig function given that sine u is 5 over 13, so I've written that over here on the right, and then that cosine v is negative 3/5, so that's written over there as well. Okay, so now we're supposed to do sine u plus v. So one thing we know this formula is on page 380. So we go write it down. It's very long. It is sine u cosine v plus cosine u sine v. So I can see that I'm going to need to fill in a lot of stuff here. So let's see what we already have, and then we'll see what we need to find. And that's the thing, is we're going to have to go find some things. They also tell us that this is in quadrant 2. So I'll just kind of put a little check mark over here and draw a little example of quadrant 2. Okay, now one of the reasons that might be there is because, we got that all students take calculus thing. We're going to have to go find some values, and we're going to need to know whether they're negative or positive. All right, let's fill in what we know. We know that sine u is 5 over 13, and that's right here. And that we know that cosine of v is negative 3/5. But what we don't know is what is cosine u, or what is sine v. That's not information they gave me, so I'm going to have to go figure it out. So in order to do this, I'm going to need to think about what I know about some right triangles, and we're going to do this. This is stuff from back in chapter 4 that you did. If I know that sine u is 5 over 13, let's make my u be right here. Okay, we'll call that the u. Again, very small. I'm trying to write with a pretty fat stylus, so you're going to have to bear with the writing here. Now, sine is opposite over hypotenuse, so the opposite side is 5 and the hypotenuse is 13. And if you think, this is a triple, isn't it? It's a 5, 12, 13. So my missing side right here is a 13. Why did I'm sorry, it's a 12, not a 13. It's a 12. Why did I need that? Because now if I want to know the cosine of u, the cosine of u is going to be the adjacent side over the hypotenuse, so that's going to make cosine u 12 over 13. So I can go fill that in. That's 12 over 13. So you can see that red work. I put it up in red when I plugged it in. All right, now what about v? We knew the cosine of v, but we do not know the sine of v. Oh, by the way, I need to check something really quickly. I just found the cosine value, didn't I? And they said this angle was in quadrant 2. Cosine is not positive in quadrant 2, is it? So I actually need to put my negative on this before I go on. So let me go in and do that. So that's something that as you do these problems you kind of have to think about is sticking that on there. Okay, now let's find the cosine of v. I'm going to try to squish it in down here because I don't want to have to try to recopy on a new page. This thing doesn't let me advance and see the old page. All right, so here's v. We know that cosine of v is negative 3/5. It makes sense that it's negative because it's in this quadrant 2 right here. But see, we know the cosine of v is 3/5. And the cosine is the adjacent side over the hypotenuse. So I'm going to label in green just to have a different color for us to use. So the adjacent side is 3 right here, and the hypotenuse is 5. Oh, look, they were nice to us. We didn't have to do the Pythagorean theorem. We got a triple here. It's a 3, 4, 5. So my missing opposite side there is 4. And why do I need to know that? It's because they want me to fill in what is sine of v. So in order to figure this sine of v out, I had to go back to this right triangle to figure it out. All right, well, the sine of v, let me kind of come over here, would be the opposite over hypotenuse. So that would be 4 over 5. And let's go check quadrant 2. Sine is positive in quadrant 2. So, oh good, my answer here is just going to be a positive 4/5. I don't really have to adjust the sign this time like I did on the one that we did before, the cosine u. Okay, from now on out, it's PEMDAS. So here we go. If you look at this, you may be tempted to start canceling stuff out, but I wouldn't, and here's why. You got two things with fractions you're going to need to add together, so you're going to need a common denominator. For instance, I see that 5 and 5 would cancel out. But go over and look at the second set of numbers. There's no way to cancel 5 out over there. So even if you cancel it out, you're going to be going backwards and putting it back in, which is kind of a pain, right? So let's not reduce these. if I'm looking at this first set, the two blue numbers, 5 times negative 3 is negative 15, and 13 times 5 is 65. Now if I go to the second set of numbers over here, negative 12 times 4 is negative 48, and 13 times 5 is 65. So again, I have a common denominator. It's 65. And now I can add across the top 48 and 15. If you add those numbers up, remember if you're having trouble negative, when you add two negatives together, you're just totaling up and making the result negative. So it will be a negative, and that's going to be a 63. Now, there's no numbers that divide into 63 and also divide into 65, so here is our exact trig value given these other two things here. So, in previous problems, they were always telling us what the two angles were. Here, they didn't tell us the two angles, but they had the sine of one of the angles and the cosine of the other. So even though we were missing the angles, we could go figure all this out and still come up with an exact trig value. We do not have to use our calculators because we can actually use these formulas to get exact values. And so that's what scientists do when they need something really exact. I mean, I'm sure some of today's computers probably go out to enough decimal spaces. They've got enough memory to hold a lot of decimal spaces, so they may be able to just let the computer calculate all that stuff. With computer functions and not actually doing this exactly. But an interesting thing would be to watch that movie Hidden Figures and watch what they're doing with that math as she's calculating things, and you're going to see some of this stuff show up in there. Anyway, so this is how we would do 35.